What we're going to look at today is neutralization. We use this along with universal indicator to figure out how strong or weak an acid or alkali is. What you may not know is that inside your stomach there is an acid, and this acid is known as hydrochloric acid. And this is what causes the phenomenon of indigestion. If you eat too quickly, what you can find is your stomach gets filled up with the food, the acid produced by the stomach to help destroy pathogens, which are microbes which harm you, and to enable your digestive enzymes to work. That acid begins to enter your esophagus, and your esophagus is unprotected from it. Your stomach has a lining which actually can resist that low pH, but your esophagus, the tube through which you swallow your food, does not have that lining. And so if the acid ever gets pushed up into your esophagus, you end up with a nasty pain or a burning sensation in your chest. Indigestion. So what we're going to do now is look at how indigestion tablets actually work. They relieve that suffering almost instantly. So let's find out what they do. Now, it's all based off of a chemical reaction known as neutralization. If we mix any alkali with an acid, the pH will begin to move towards neutral. Now, if you get it perfectly mixed, an acid can be completely neutralized down to 7 with any alkali, as long as the alkali is added in the right proportion. So when you have indigestion, the low pH of your stomach acid is causing this uncomfortable symptom, this heartburn or this indigestion. So what we normally do is we would eat an indigestion tablet. Now, indigestion tablets actually contain calcium carbonate. With a pH that's quite close to 7, they are able to slowly change this pH 1 and shift it towards 7. The more of this you add, the more this pH will rise. So your stomach acid slowly moves towards neutral. And so we call this reaction neutralization. Well, let's look at it in action. Out of the packaging, and we will grind it up in a pestle and mortar to simulate the act of chewing it up before swallowing. So when it goes, we're just going to grind it up inside the pestle and mortar. This represents our teeth chewing it, broken up into tiny particles. There we go. Next, we're going to add a bit of water to that, and then we can add some universal indicator to see the colour. So a test tube of water, in it goes, and we're going to mix that together. We'll pop that back into the test tube. We're going to quickly add a little bit of our universal indicator just to see what colour it turns. Give it a swirl. You can see there, that's a very dark green. So it's not quite neutral, it's slightly alkaline. But as I said, you don't need a very strong alkali to combat a strong acid. As long as you've got enough of the alkali, it's going to slowly reduce this pH from pH 1, reduce the acidity up to pH 7. So again, here's our hydrochloric acid. I'm going to pop a little bit of that into this tube just to show you that it is an acid. So by adding my universal indicator, you should know what colour it turns. Acids, or strong acids, will turn a nice deep red. So there you can see it is an acid. I've only had one drop there and it's already quite a deep shade of red. So what I'll be doing is adding this hydrochloric acid to our indigestion tablet there, the weak alkali, and we're going to see what happens. So now we're going to add our hydrochloric acid 1 drop at a time to see how it affects our indigestion remedy. Oh, there are about 3 drops. You can see it starts off red at the top, but if I give that a mix, you can see the red colour's gone. It's begun to become neutralised. So it is now a nice light shade. It's between 6 and 7, but I did add a few drops in. I'll add a few more, and we'll see what happens. Oh, there are another 3 or so. And again, look, it's red at the top, showing the acid is quite strong. Give it a swirl, and you can see it's gone to a yellow. Now, the yellow is not going to be uncomfortable within your stomach. That's a very weak acid. We can add a bit more, though. You can see this is actually slightly changing slightly towards the green again. We'll add another few drops. Here we go. Oh, there was another 5 drops. And again, you can see it's acidic as it goes in. Give it a swirl. Starts off red and then begins to neutralize. It's gone down to 6 again. We can add some more. Remember, this hydrochloric acid is very strong. It's about a pH of 1. Oh, there were 2, another 3, 4, 5 drops. Starts off very strong. It's a pH of around 1. But once it mixes in with the antacid, the indigestion tablet, it's neutralized. Well, it's not fully neutralized, but it gets down to pH 6 each time I add it. Now this will be able to neutralize quite a large amount of the acid. The average stomach contains anywhere between 20 to 100 milliliters of acid at any one time. Again, I added about 6 drops there. It's acidic at the top. As soon as it mixes in, it's neutralizing. It's beginning to get a bit more towards the lower pHs. It's at around a pH 5 or 6 at the moment. But again, I am adding a considerable amount of acid to this. Each time I'm adding about 5 or 6 droplets, and it is effectively preventing it staying acidic. It's beginning to neutralize that acid and raising its pH to 7, which is the neutral pH. Again, let's have a big old squirt there. We'll see if we can overcome it. Give it a swirl. And look, even with a large squirt of acid, it's still around pH 5. And pH 5 isn't going to cause you any major discomfort. What the acid is actually doing then, as it reacts with this alkali, is being neutralized. And there's an equation for this that we're going to look at now. This is what we call the general equation in the reaction between any acid and any alkali. If we have an acid and we react it with an alkali, we produce a salt plus water. What the alkali in the indigestion tablet is actually doing is turning the acid into water. It's turning this low pH acid, pH 1, is raising its pH to 7 because it's turning it into water. And as you know, water has a pH of 7. The salt, well, there are many, many types of salts. That depends on which acid we're using and which alkali. Now, an alkali is just a soluble base. Will neutralize an acid. Alkalis are bases which dissolve. They're soluble bases. And the reason this works, every acid contains hydrogen ions. Alkalis contain hydroxide ions, which are OH negative. Now what's going to happen is when we react H's with OH's, we get H2O. And if you know your chemistry, you'll know that H2O is the chemical symbol for water. So a part of the acid, the hydrogen ion, reacts with a part of the alkali, the hydroxide ion, and it becomes H2O, which is water.